this chapter, this is the last. Honestly, this is the last section in this chapter already. So, like we were saying yesterday, our best guess is that we'll probably be able to test through this chapter. Remember, it's a 3-day weekend, so we don't have school on Monday. I would give you a test on a Tuesday, coming back on 3-day. At the very earliest would be Wednesday. I'm probably more or less thinking Thursday. That way we get some time to go through, make sure everything's all tied up, and go from there. But we'll see how it goes coming in tomorrow and playing everything by ear. So with this last little bit, this last section is called proportions within triangles. And what happens here is that there's going to be basically 3 generic formulas. And the formulas aren't things that you have to know. The formulas are going to be things that when you look at a diagram that you can use. Okay? And what's nice is that they're really, really, really easy. So one thing that happens in triangles is that sometimes you'll see a picture that looks like this. Okay? When you have 2 parts that are parallel, 2 sides that are parallel drawn inside of a triangle, you're going to get a special type of ratio that occurs. And what's nice about this is that no matter what the numbers are, what the sides, or what everything looks like, you're going to do the exact same thing every single time. In this case here, does everybody agree that that line RS is somewhere in between in the triangle? I don't want to say in the middle, but it's in the triangle somewhere. Yeah. So it separates this part and this part, this part, and this part. You guys okay with that? How it separates it? How many sections are now there? 4. Yeah, on the sides. I'm sorry to rephrase it. There's 4 in total, right? So watch what happens. Treat this as a fraction bar. What's happening is this chunk here that middle-ish parallel part splits it into fractions. That's how this works. It's super, super easy because you'll see it visually. I'm sorry, I hate to know that you're in crisis mode. Here's an Air 5. I don't care anymore. I'm trying to. Okay. Anyway, so remember, all this is doing is that middle-ish parallel part is splitting it into the fractions. Treat that middle line as a fraction bar. It's super easy as you visualize through because what will happen is this. We'll get a diagram that looks like this. You've got 2 parts that are parallel. Notice the sides. There's 4 pieces. This is playing the role of a fraction bar. And it's quite literally 12 over x plus 1 is 9 over x. It splits it into its fractions. Okay? Pretty much. I apologize.
It's okay.
All right? It's one of those things that as you go through these things, there are certain little tricks of things that show up, and this is one of them. It splits it right down the middle. I don't go through the definitions. I don't want to bore you with all the proof of how all this works. I just want you guys to see if you've got 2 parts that are parallel, that middle-ish piece, treat it as a fraction bar, and you got top over bottom, top over bottom. Worst case scenario, what happens if your picture is rotated like this? What are you going to do? You're going to do the same thing. What are you going to do to your paper to make it look right? You're just going to turn it. All right? Does that make sense? That's all it is, guys. Okay? So now what do you do mathematically wise, or mathing wise? Cross multiply. So you get 12x, 9x plus. Very good. Okay. And now you have variables on both sides of the equation. What are you going to do? Subtract. Yep. Subtract the small one, you get 3x. And x is. Okay. Can we make this more difficult, you think?
No, we cannot.
I mean, I could, but I'm not doing it. Be all right on this one?
Yes.
All right, let me show you the other one. All right. So I'm trying to. How many lines are parallel now? 3. Okay. Now I had 3 lines that are parallel. I have 3 lines that are parallel. There's 2 transversals. What do you think that middle parallel is going to be treated as? Fraction bar. That middle one, that middle parallel. And remember, it's not exactly in the middle. We're just calling the middle-ish parallel part. We're going to treat that one again like it's a fraction bar. So what's going to happen here is that this guy plays the role of a fraction bar. So you get these sections that are created for the numerators, denominators. It's basically the same thing we just did, except that it doesn't all the way up to a P. All right? It's the same basic principle. So you're going to get AB over BC, WX, XY. Treat that middle parallel just like you would a fraction bar. If you go through that mindset like I was showing you, like in that first example, that middle-ish line is a fraction bar. This middle-ish line is a fraction bar. They're kind of the same problem. Okay? And then it's just a matter of, once again, writing it down correctly and cross multiply. Okay? Treat it just like you would a fraction bar. And it works. Excuse me. All right, let me show you an example. And I spun this one so it wasn't straight up and down. What's that say? BC. And then I think it was... Yeah, or WXXY. Sorry, Sam, I didn't realize. I apologize for getting that together. All right. So in this one here, do you have 3 parallel lines? Yeah. It's just sideways. So what would you do? Turn it, right? If I turn it, does it matter which way I turn it? It does not. You're right. It does not matter. Okay. You just make a choice. If you want to turn it to the left, turn it to the right. I'm just going to go like this. Yoink. All right. Can you still read the numbers if it's sideways?
Yeah.
Because you can turn your head sideways, right? Remember, treat the middle-ish parallel as the fraction bar, and it creates your fractions for you. So if you have that middle-ish, we have what? 62 over x, 56, and 70. Okay. From there, it's just a matter of, do you want to simplify the 56 and 70 right away, or just use your calculator and cross multiply? If I simplify, I believe if I divide those both by 7, I get, what is that? 8/10. 8/10 is the same thing as 4/5, isn't it? Okay. So if we cross multiply here, 5 times the 62, that's a 0, carrying the 1, 31, 310 is 4x. Okay. Now, when you're fine that you have a decimal, because watch what happens. If you divide that by 4, remember, when you divide something by 4, you're basically cutting it in half twice. Do you guys know that? Okay. What's half of 310? 155, right? And then you do half of 155, you're going to get a decimal. So what'd you get? Yeah, it's fine. And there you go. Yeah. You can get decimals. It's okay. It's okay. And I know you guys have this huge aversion to getting decimal answers. Just so you're aware, you're going to get more and more and more of them as we go throughout the semester. Okay? Especially next chapter. We're going to have a lot more of them. When we start dealing with angle measurements and side measurements with some trig setups and stuff. Yes, sir?
These problems we don't need in math.
You can leave it as a fraction. If it gave you a fraction, that's fine. It depends on, honestly, it depends on how you typed it into the calculator. If you typed it in the calculator, fraction bar 31/4, it would spit it out as a fraction for you. But if it gives you a decimal, it's okay as well. It's not the end of the world. Especially when you get stuff that's 0.5, 0.25, something along those lines. It's still a problem. Right? Was that terrible though? Okay. Here's the last one then. You're gonna love this one. Yes, sir.
So I'm going to be distracted. Like, picture this guy. So like there's two big old fat folks, right? They're right? And there's like a big old rotating machine that goes around, right? But it's still like facing the angle from the sun. Okay, so you know how the Earth is moving closer to the sun, right? And it's got built-in rockets that will push the world and move in our own direction. Push it around. But it's got to be in a certain point. This is what you're itself. You don't know how to have that moment. You know what I'm saying?
Okay.
It's constantly always getting things going with it. Okay, because it's going in different directions. So that's one direction. That's what it's
Gravity.
there you go. You see what I mean? So it's got to keep in position. You see that? Took up ass.
Awesome. Took up aces. Alright. I'm just messing. So here's the weird one. And I jokingly said that you're gonna love this one, and there's a really cheesy reason why I say that. What do those tick marks mean at the top there? The angles are the same, which means that the angle was bisected. Are we okay with that? So what happens here is when you have what's called an angle bisector in a triangle, this angle bisector, if you follow it out and around, it kind of looks like a heart.
Upside down butterfly. It looks like a flywheel. No,
It's just bad. But anyway, what happens is, as you go out from the angle, you get to your numerator. When you come back, you get your denominator. As you go out, numerator, denominator. As you go out, numerator, denominator. When you have the angle bisector, you say we go out and around. The out is the numerator, the around is the denominator. It's the weird looking one. All right, we go out and around. It's, bless you, as long as you're consistent, bless you, it does work, bless you. Bless you.
Oh no.
Wait, yeah, go ahead. So as long as it's consistent, but I like the idea as you're going out, you know where to start, and you come back. So as you go, and I wanted to make sure you saw it, even though it's upside down, I still say that's my denominator, my numerator, and I come back to my denominator. It's just an easy way of doing it. And then from there, it's just cross multiplying. Can I simplify 15 and 25? Yeah. What do you get? Good. So you have 3/5. You have 9 over x. Cross multiply here. We have 3x. Excuse me. Is what? 45. You get 15. Okay. It's the cheesiest of all of them. I mean, as you can probably tell right now, these are pretty ridiculously simple. It's just the idea that you pick out which one you're using. The other two are obvious, the parallels. That middle-ish parallel line is always a fraction bar. Always, always, always. This one, you just have to remember, you go out, then around. I think I know that. So this one, same idea. Oops. And I drew it, I had it set so you see how it goes out and around. Okay. If we keep the consistency of always working out from the bisector, that gives you your numerator. Come around to your denominator. All right, and that's why I was jokingly saying you were going to love this one. What's it?
That's perfect.
This leads to which
Well, bless you, please.
What is it?
So you loved this one.
I do. You know what?
It's like me. I have a big heart.
Hey, don't you liar.
Ouch! Ouch! Hey, could you do me a favor? Would you take the knife out of my back on that one?
I'm not
Jeez.
trying to be.
No, I'm messing with you.
I'm not even going to
I thought that was cheesy enough.
You're right. This is cheesy. That's cool. That's what I'm
Alright. Anyway, so when we do one like this, as you follow the lines of it, you go out and around, so it's 18 over x, go out and around, it's 10 over 12. Always the out is always up top, the around is on the bottom. Out and around. It is probably one of the, like I said, there's no reason for us to go through the definitions and the long-winded proofs of how all of this works. Because if you could recognize what it looks like via the picture, everything's pretty easy. Okay? Go out and around. Let's see. Yes, this is what? 5, 6, 18 over x. So we have 5x. Let's see, that's what is the 2? No, 8. 8 for 108, is that right? Yeah. Divide that out. 21.6.
Bro, what? Nunca pensas en ser gente.
Gracias, señor.
I call my buddy, the manager said, yeah. He's like, I'll come see you, I'll come with my name. Like, why you not here? He's like, it's not respect. Slow, right? I think he just wants to be like, I don't know. So they don't have a name.
It's all right.
I call him by that.
That's all right. And that's cool. You show them the respect like that. I mean, like our kids, like our friends, our neighbor friends and all that. It's like Mr. Nick, Mr. Keith, Mr. You know, that's what they always say. Hi, Mr. Nick. They always call him that. They always say that. So pretty easy, right? Let me get you some examples. There's a couple I want to show you that. You know how we've been using those CUDA sheets pretty regularly? Those CUDA sheets have a tendency from time to time to show you some of these things that can get a little bit messy. And I really didn't make this many of the problems on here. We're not going to do all this, so don't worry.
You know what's crazy though? You gotta be careful. You gotta be able to blend that up. All that powder. You gotta make sure you have the panic. That's for other, like, if you're able to do that with your own panic, you gotta predict. You know, so it's like space, like, gravity has on Earth, right? But like, it's just like, you have to space things too, right?
So, a few things in here. Let's see where we're at. Here we are. Now, what I was doing with these things, I wanted you guys to see that even though the setups are relatively easy, I wanted you guys to see that there can be a little bit of trickery with the algebra if you're not careful. For example, when we look at number 1, You have to be careful how things get backed out. All right. CUDA is notorious for doing stuff like this, so I figured the more I show you, the easier you'll be like, oh yeah, I just subtract that other chunk and it'd be a smaller piece. Okay. On 2. 2 has the 2 parallel lines inside of a triangle, which means that middle-ish line is going to act as a what? A fraction bar again, okay? So I know that no matter what, one part of my fraction is going to be 9 over 15. Are we okay with that? That'd be 15 over 9. And then I'd have to put the 35 on the top for the other side. Okay? I also know that the bottom denominator on this side is going to be 35 because there's nothing else to it. It's given to me at that value. What I have to figure out is that small chunk up top. Remember, the whole thing is the 7x plus 7. I have to back out 35 from that. So this chunk is 7x plus 7 minus the 35. Okay? That's the little trick part where you have to be careful when you're given the whole. To get this other piece, you got to subtract the other part. All right. Just like I know you guys know how to add the two together to get pieces. This one you have to back out a piece. So what's 7 subtract 35? Yeah, you get negative 28. So here's 7x minus 28. Okay. Now from here, you can do a couple of different things. I have the 9 and the 15. They're both divisible by what? 3. Good. Do you see any common value here with 7, 28, and 35? 7. But do you have to do that? No. I would just leave. I mean, honestly, if I wasn't using the calculator, I would simplify it, but I have one, it's no big deal. Here, I would just simplify because that's pretty quick. 3/5. And then I have 7x minus 28 over 35. Now I do my cross multiply. I'm sorry. So now I distribute out my 5. I get 35x. Excuse me. It's minus 28. Sorry. Minus. Let's see. That'll be a 140. Is that right? And then 35 and 3, I believe, is 105. 2-step equation. Boy, we've done those once or twice this year. Maybe. 3 times? I don't know. I lost count.
Isn't there like a website where you can no, but I've heard it. Like, I know it for a fact because I know about this. Like, there's a slew of things that you can share. It's like crazy.
And then I divide out by 35. What do you get? Is mathing of this terrible? No, it's not that bad. It's all kind of the same stuff. It's all kind of the same stuff.
You gotta do is just like put it in with the other. Like that. You get out.
Okay. Let's take a look at what is the other one.
Oh my God, this is that good.
Yeah, I did a lot. I just put a bunch of them on here. That way we have more examples. I always like the idea of having more than you need. And there's no way we're going to do all of these. We're just doing a couple of them. Just for examples, we don't have to keep drawing. I'm sorry, what was that, Sam? Yep. Very good, sir. Once again, which of the 3 is it? Is it the one that you, air quote, love? Or is it the triangle? Or is it the 3 parallel lines? The 3 parallel lines. This is number 3, yeah. It's the 3 parallel lines. So we just have to make a quick decision on kind of what way we want to shift it a little bit so we know how we want to set up our fraction bar. Do you guys want to shift it this way or do you want to shift it the other way? I'm kind of thinking this way, towards the counterclockwise a little bit. So I go a little bit counterclockwise. I get this. Are we all right with that? So now I've got my fraction bar-ish thing here. All right. So I know, again, I have that 3 over 6 on one side. I know my numerator is the x minus 3 because it's given to me, but the whole thing is 15. This is the screwiest of them all. Notice what we've always been doing. We've been taking the whole thing and subtracting what we had here to get the other part. Remember that? Now when you subtract, you don't have just a number, you've got a term. Whenever you subtract a term, you have to put it in parentheses. That means that this piece here is going to be 15 minus x minus 3. Most of you will forget that because in essence here you have to now distribute the negative. So you get 15 minus x plus 3. So this is 18 minus x. Because remember, if you add those two chunks together, 18 minus x plus x minus 3, it has to equal 15. Okay? Whenever you're subtracting a term, you have to put the term within parentheses. If you don't put it in parentheses, you're going to get it wrong. All right? So that denominator here is 18 minus x. Before I cross multiply, what am I going to do to the 3 over 6? Yeah, what do you get? Here, I'm just going to rewrite that as 1/2 real quick. Now I cross multiply. So 18 minus x, 2x minus 6. Add x, add 6 coming back. And I get 8. What'll happen with you guys on the ones like this where you have that secondary term to distribute the negative to, you're not going to get really clean numbers at all. And that's why you're going to know that you did something stupid or you screwed something up. Yes?
You're figuring out the 18 minus x.
Yeah.
And you have the 15 minus parentheses x.
Yeah.
How did you go from that to the 15 minus x plus?
What happens here is the number that's out in front of this that you don't see is a -1. So you have to distribute the negative to both parts. So you have -1 times negative x is negative x. -1 times negative 3 is positive. That's where that's coming from. All right? And that's what happens. And that's the goofiest of these things that you'll see. The majority of the problems are, I mean, you saw this, they're really easy. Yeah, I'll get there. I just wanted to make sure everybody got this one okay? All right, let's look at 4 then. Yeah, this is the reason why I had all these extra pieces or extra problems in here to go through a ton. Okay.